through projects. In this video, we will explain about the project, which is hateful sentiment detection in real-time tweets, an LSTM-based comparative approach. Introduction of the project. With the internet hosting over 4.5 billion users globally, social media platforms like Twitter have become integral, but this widespread connectivity has also given rise to challenges such as an upsurge in hate speech, particularly evident during events like COVID-19 lockdown. Automated hate speech detection for recognizing the impracticality of manual moderation in handling the increasing volume of hateful content. This project pivots towards automated detection methods employing natural language processing and machine learning models. The project opts for a synthesized data set which is fake Twitter data. This deliberate choice provides a controlled environment for studying hate speech patterns, ensuring a focused and controlled exploration. The project utilizes natural language processing techniques including pre-processing, normalization, and term frequency inverse document frequency, which is TF-IDF method. The TF-IDF technique assigns weights to words based on their significance in the corpus, aiding in the identification of hateful and not hateful tweets. The project incorporates deep learning, specifically LSTM models for hate speech detection, with an emphasis on its efficacy. Comparative analysis with traditional ML models serves to validate the proposed methodology, showcasing its ability to discern hate speech patterns within the synthesized dataset. Objective of the project. The primary goal of the project is to construct a hate speech detection model employing long short term memory, which is LSTM, and machine learning techniques. The emphasis is on effectively identifying and categorizing offensive messages to address the harmful spread of hate on social media platforms. Another key aim is to conduct a comprehensive comparison of the proposed LSTM based hate speech detection model with established algorithms such as support vector machine, naive Bayes, logistic regression, XGBoost, random forest, k nearest neighbor, artificial neural network, and bidirectional encoder representations from transformers, which is BERT. The goal is to assess and contrast the overall performance of the different algorithms in hate speech detection. The project aims to integrate the term frequency inverse document frequency, which is TF-IDF vectorization technique, into the hate speech detection model. The objective is to enhance the model's capability to identify and prioritize significant words and phrases associated with hate speech detection effectively. An essential objective is to validate and authenticate the hate speech detection model using the dataset of Twitter fake data. This deliberate choice provides a controlled environment for studying hate speech detection patterns, ensuring a focused exploration. The final objective is to assess the performance of the hate speech detection model, focusing on key metrics such as precision, recall, and F1 score. This allows for a comparative analysis of its effectiveness against existing models, taking into account the unique considerations of using a synthetic dataset. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this initial step, the project begins by importing essential Python packages and libraries. This involves incorporating tools such as Pandas for efficient data manipulation, Matplotlib and Seaborn for visualization, Scikit-learn for various machine learning tasks, and TensorFlow Keras for deep learning models, Flask for web development. The next step is exploring the dataset. This step involves loading the dataset, which is Twitter fake data, and conducting a thorough exploration. The dataset structure is examined, potential missing values are identified, and in-depth analysis of class distribution is conducted. Insights into available features within the dataset are also gained. Coming to visualization, we have visualized the data as sample outcome. It is a subsequent exploratory step. The project visualizes a subset of outcomes from the dataset. This provides a clear representation of the distribution of hate speech and non-hate speech instances. Coming to word cloud is generated to visually depict the most frequently occurring words in the dataset. This technique offers a quick overview of the prevalent terms. Coming to data processing, in this step, the text data is pre-processed by eliminating URLs and unwanted characters. Punctuation marks are stripped from the text to focus on the content of words. Commonly used stop words are removed to enhance the relevance of the remaining text. The data is normalized, potentially involving the conversion of text to lowercase. The next step is tokenization. We have used counter vectorizer. Count vectorizer is text processing tool that converts a set of text documents into a matrix of word counts, facilitating numerical representation of textual data for machine learning models. It involves tokenization, counting the occurrences of each word and creating a sparse matrix where rows correspond to documents, columns to unique words, and values to word counts. So here, text is transformed into numerical vectors using the count vectorizer, a technique that represents bag of words model. Keras tokenizer. Text is tokenized specifically for neural network models leveraging Keras library. It facilitates transformation of textual data into a format suitable for deep learning models. BERT tokenizer. The BERT tokenizer used in conjunction with BERT-based models. It employs word-piece tokenization and contextual information to process text bidirectionally, capturing nuanced linguistic relationships for improved natural language understanding in NLP tasks. It breaks down words into sub-word units, enhancing flexibility in handling vocabulary and considers both preceding and following words to create contextualized representations. Feature selection. In this phase, relevant features which are words or tokens are identified and selected for subsequent model training. Splitting the data into train and test. In this step, the dataset is divided into distinct training and testing sets. The training set is employed for model training, while testing set is reserved for evaluating model performance. Building the model. This is critical step which involves the actual implementation of various machine learning models and deep learning models. Training the model. The models are trained using the designated training dataset, allowing them to learn patterns and relationships within the data. Flask framework with SQLite for sign up and sign. The project transitions, building a web application using Flask, a web framework in Python. SQLite is incorporated to manage user authentication, including sign up and sign in functionalities, ensuring a secure user experience. User gives input. User interact with the web application by providing input, typically in the form of text. Input pre-processing for prediction. The user input text undergoes pre-processing step which is similar to those applied during training phase, ensuring consistency and accuracy in the subsequent predictions. Train model is used for prediction. The pre-processed user input is fed into the previously trained machine learning models, which then predicts whether the provided text contains hate speech. Applied LDA model for topic modeling. The project applies latent dirichlet allocation, which is a probabilistic generative model in natural language processing used for topic modeling, where it assigns topics to documents based on the distribution of words, uncovering latent thematic structures within a corpus. Here, LDA is used for topic modeling on the user input text. This step aims to extract latent topics present within the text beyond a binary hate speech classification. Final outcome is displayed through frontend. The results of the model predictions and topic modeling are seamlessly integrated into the web application's frontend. User can visually assess the outcomes, providing them with valuable insights derived from the model's analysis. Now we will know what are the algorithms used in the project. The first algorithm is support vector machine. It is a supervised machine learning algorithm that aims to find a hyperplane in high dimensional space to separate data into classes. It maximizes the margin between classes, making it effective for classification tasks. In the project, SVM is utilized for its ability to handle high dimensional data and find optimal decision boundaries, making it suitable for hate speech classification. Coming to naive Bayes, it is a probabilistic algorithm based on Bayes' theorem, assuming independence between features. It calculates the probability of a label given certain features. In hate speech detection, naive Bayes is chosen for its simplicity and efficiency, making it suitable for processing textual data. Coming to logistic regression, it is a statistical model used for binary classification. It models the probability of a binary outcome using the logistic function. Despite its name, it's a classification algorithm. Logistic regression is chosen for its simplicity and interpretability in the project. making it well suited for binary classification tasks like identifying hate speech. Coming to XGBoost, which is extreme gradient boosting. It is an ensemble learning algorithm that combines multiple weak learners to create a strong learner. It is designed for speed and performance, and it is known for its efficiency in handling imbalanced datasets. In the project, XGBoost is selected for its robustness and high performance in classification tasks, providing accurate predictions for hate speech detection. Random forest. It is an ensemble learning method that constructs a multitude of decision trees during training and outputs the mode of classes as prediction. It is robust, handles noise and outliers well, and it is well suitable for unbalanced datasets. In hate speech detection, random forest is employed for its ability to handle real world scenarios. K nearest neighbor. KNN is a non-parametric, lazy learning algorithm used for classification and regression tasks. It classifies data points based on the majority class of their K nearest neighbors. KNN is chosen for its simplicity and adaptability to various data distributions, offering a straightforward approach to hate speech. ANN with MLP, which is Artificial Neural Network with Multi-Layer Perceptron Architecture, is a deep learning model consisting of interconnected nodes organized in layers. It is capable of learning complex patterns in the data. ANN MLP is employed for its ability modeling intricate relationships within the data, making it suitable for hate speech detection in diverse textual content. The next algorithm is long short-term memory. It is a type of recurrent neural network designed to capture long-term dependencies in the sequential data. It uses memory cells to retain and propagate information over long sequences. In hate speech detection, LSTM is chosen for its effectiveness in handling sequential data, capturing the contextual nuances of language. The last algorithm is bidirectional encoder representations from transformers, which is BERT. BERT is a transformer-based language model pre-trained on large corpora. It captures bidirectional contextual relationships between words, and it is widely used for natural language understanding tasks. BERT is selected for the state-of-the-art performance in NLP tasks, including hate speech detection. It excels in understanding the context and nuances of the language, enhancing model's accuracy. As an extension, we applied ensemble model and hybrid model that combines the predictions of multiple individual models to produce a more robust and accurate final prediction. As an extension, we also built front-end using Flask framework for user testing with the user authentication. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate this project. So here we have performance comparison graphs for all those metrics. The first graph is the accuracy comparison graph. Here on x-axis, we have accuracy score for each algorithm, and on y-axis, we have algorithm names. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. Precision comparison graph. Here on x-axis, we have precision score for each algorithm, and on y-axis, we have algorithm names. Precision is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall score comparison graph. Here on x-axis, we have recall score for each algorithm, and on y-axis, we have algorithm names. Recall is also known as sensitivity or true positive rate. It measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. Here on x-axis, we have FN score for each algorithm, and on y-axis, we have algorithm names. FN score is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the pages, which is HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of codes, graphs, and outputs all in one place. It allows users to execute code in individual cells, making it a popular choice for the data science. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file exploded. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First, we need to click on that and enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a text box where we need to give the input message. Based on the given input message, the system will classify whether the tweet belongs to hate speech or not hate speech. So here I'm pasting the message. Now click on predict. Here we got the prediction as tweet type is hate speech. The application has classified this particular message as hate speech. And the topic for the paragraph is most dependent upon these words. Now we will give the other message and see what will be predicted. I'm pasting the message. Now click on predict. So here we got the prediction as the tweet type is hate speech, which means the application has classified this particular tweet, which is message, as hate speech. And the topic for the paragraph is most dependent upon these words. Now click on sign out. In this way, if we enter the message into the system, then the system will predict whether the tweet is hate speech or not hate speech. Conclusion of the project. The project successfully establishes a comprehensive framework for hate speech detection by leveraging a diverse set of machine learning and deep learning algorithms including SVM, naive Bayes, XGBoost, LSTM, and BERT. Through meticulous data processing steps, including URL removal, punctuation cleaning, and stop word elimination, coupled with advanced feature engineering techniques like TF-IDF and tokenization, the project ensures the robustness of the model in handling textual data. By incorporating a range of algorithms from traditional methods like logistic regression and random forest to advanced deep learning models such as LSTM and BERT, the project conducts a thorough comparative analysis, highlighting the strengths and weakness of each approach in hate speech detection. The implementation of Flask Web Framework with SQLite for user authentication ensures a user-friendly experience, allowing users to input text for hate speech prediction. This integration enhances the accessibility of hate speech detection systems. The project benefits social media platforms, online communities, and users by providing advanced hate speech detection, enhancing user safety, and fostering a positive digital environment. It also aids content moderators, researchers, and law enforcement in streamlining moderation efforts, contributing to a more inclusive and regulative online space.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Project's YouTube channel and subscribe.